Hello, I'm Max Bueller. I'm here with Kenzie Van Beek doing IVL5. Today we'll be discussing the dogfish shark and a couple of the different systems of the dogfish shark, specifically the digestive system, the excretory system, digestive system, the circulatory system, and how blood flow flows to the heart, to the gills, the systematic system, circulatory system, where blood is flowing throughout the dogfish shark's body, and the reproduction system and the difference between the male and the female reproductive system.
In this video, we're going to talk about the visceral organs. To start off, we're going to talk about the liver in the dogfish shark. It is large and takes up most of the pleuroperitoneal cavity. There's two lobes, as you can see here. There's one and two down here. Next, we're going to have the bile duct, which is farther dorsally. It's kind of behind the liver there, and it goes from the beginning of the liver to the beginning of the intestine here. Between those lobes of the liver is the esophagus and the stomach. If you can try and pull out and see this here. Here you can see those two around this region. They're more dorsally located, and the stomach has a curve, giving it a J shape. Its function is to digest and break down food, and the esophagus helps get the food to the stomach, and it secretes a mucus to help aid it to get there. And then as you go farther down, this is going to be the valvular intestine, and that was going to turn, if you keep going, into the cloaca, and that is where the chamber that receives the intestine and the genital ducts are. That's where fecal matter is expelled in the digestive system. You can kind of see the hole here. And then there's a spiral valve within the intestine. This purpose is to help slow down the passage of food and make digestion more efficient. It also increases the storage area so the nutrients can be absorbed over a longer period of time, and we'll kind of talk about that at the end of the video. Next, we're going to talk about the spleen, and the spleen is here. The spleen is attached to the caudal end of the stomach. It's like this triangular shape. It is related to the production and storage of blood cells. And the pancreas, which is responsible for producing digestive enzymes and metabolism, is related to metabolism in the shark. It extends from the right side of the spleen, and then it goes and attaches to the surface of the intestine. Lastly, and you can see that here, be a little more clear. And then lastly, we're going to talk about the digitiform, or the rectal gland. That is responsible for salt excreting. And in sharks that go into fresh water, it undergoes a lot of changes. If you can see here, it's finger-like, very small. So yes, that is the digitiform rectogram. So now we're going to kind of talk about the shark's eating habits in its environment. The shark goes days within weeks without eating, and so big meals they need to digest to be slowed down. So that's what the spiral valve helps to do. It needs to absorb as much nutrients as possible. They are the peak predators, and they eat large chunks of prey. So the stomach functions as a chamber for food storage, and the large area helps the shark's metabolism slow down, which comes the metabolism is responsible for the pancreas. And it allows it not to eat for longer periods of time, so the spiral valve helps it do that. And coming back to the liver here, the shark does not have a swim bladder, so the liver is responsible for keeping the shark buoyant. So it helps in the locomotion. Most of the shark's total weight, like 25% of it, is due to the liver. The liver stores large amounts of oil to obtain buoyancy. This is more effective, allowing sharks to move up and down faster than a normal fish with a swim bladder. So that's why it helps aid them in being a peak predator, as long as other obvious features, but it allows them to be quicker and move where they want to faster. So those are the visceral organs. In this video, we're just going to talk about the basics of the pleuroperitoneal cavity, which is the body cavity of the shark that contains the chest and the GI tract. It is lined with the epithelium, which is the shiny portion of the shark. You can see. The portion of the epithelium adjacent to the body wall is the peritoneum. They meet from each side dorsally and ventrally. This creates a double-walled mesentery. Also contributing to that mesentery is the visceral peritoneum extending from the body wall to the viscera. This is the membrane that's going to cover those visceral organs. And now I'm going to talk about the urogenial system of our shark. Our shark is a male, and what can help you determine this would be the testicles that you can find within the pleuroperitoneal cavity. There is one right here, and the second right here. Those testes are located anterior to the kidneys, and the mesoarchimium is here, and that helps support the testes and attach tubules to the testes. The sperm pass through the aphonephric duct and then descend through the cloaca. But as the duct approaches the kidney, it straightens and enlarges to form a seminal vesicle, which is going to be down here. And here's the seminal vesicle, and it's hard to see, but there is a sperm sac down there. And the sperm sac receives the seminal secretions from the seminal vesicle. It develops from an outgrowth of the aphonephric duct, and sperm are stored in both the seminal vesicle and the sperm sac. As well, it contributes seminal fluids as well. And then it'll exit through the cloaca. And we'll talk about the reproduction in a minute here. But another way you can tell that this is a male shark is by its claspers. And that helps with the reproduction of sharks, which we will talk about. So now quickly I'm going to talk about the female reproductive system, so we can talk about the reproduction between sharks to get you a better idea. The female reproductive system of the sharks consists of large organs near the front of the pleuroperitoneal cavity. Those are called the ovaries. The ovaries are supported by the mesoovarium, which is similar to that of the male shark. And the ovaries contain the eggs in various stages of maturity of the shark. When the eggs are mature, they go through ovulation, passing through into the coelom and enter the oviducts. The oviducts are connected, and they have a mutual opening at the ostium tubulae in the coelom. Ciliated tracts help move the egg to the ostium, where in the uterus, that is where the embryos will develop. And the uterus, especially when they're pregnant, occupies a third to half of the oviduct, so it gets fairly large when they're with puppies. So that is the anatomy of the female reproductive system. So then we're going to quickly talk about the reproduction between sharks. So fertilization in sharks and fish like it happen internally. Females lie there kind of quietly while the male coils around her so that its pelvic clasper, so which would be one of these guys, can be inserted into the cloaca and the oviduct of the females. Spurs on the clasper help hold it in place, and sperm passes from the male cloaca into the grooves dorsally on the clasper. The siphon contracts with seawater and secretions into discharge and propel the sperm along the clasper into the grooves of the female. Sperm moves up the oviducts of the female to the site of fertilization, near the cranial end of the oviducts, and that's how sharks reproduce.
So when discussing about the pericardial cavity in the shark, we'll be mostly discussing the shark's heart, which will be located right here. This is going to be the shark's heart. And when discussing about blood flow, it's going to be actually very simple compared to other vertebrates, because since this is a shark, it will be having a single circulatory system. And what that means is that the shark's blood flow is from the deoxy blood coming from the body to the heart, and then the deoxy blood from the body goes to the sinus venosus, down into the atrium, and then into the ventricle, going into the conus arteriosus, and then going back up to the gills, where deoxy blood will be oxygenated once more. So next up, I will be discussing the venous system, or otherwise known as all the veins in the shark. And something I'd like to point out about the veins is that they all do the same job, which is taking blood from a certain organ and taking it back to the heart to be oxygenated once more. And another thing I'd like to point out is that it will be hard to show all the veins in here, so I will do my best to show the general vicinity of where the veins are and where they connect to on the shark. First off, I will be starting with the hepatic veins, and what those are responsible for are taking blood to the liver, which is right here. It'll be on this side over here, the liver, and they are responsible for taking blood from the liver back to the heart. Next up, we got lienomesenteric veins, and that's actually going to be in here, and that's going to be these veins in here that are responsible for taking blood back to the heart from the stomach. Going down even further, we have our anterior intestinal veins, which drains blood from both the large and the small intestine and bring them back to the heart. Something we won't be able to see are renal portal veins, which supply blood to renal tubules. Next up, we got caudal veins, which actually run all the way down into the shark's caudal region, responsible for draining blood there. Along the sides here, you could see our lateral abdomen veins, which are responsible for carrying blood back to the heart from the abdomen region and also the pelvic region right over here. And then finally, our last different vein, I guess, or sinus, excuse me, will be the posterior and the anterior cardinal sinuses, which are going to be a little bit more up here. Excuse me. A little bit down here, right in between the caudal region and the abdomen region. This will be the trunk region, which is responsible for draining blood from the trunk region. So again, with the brachial arteries, it's going to be a little difficult to see the arteries without dissecting it, but I will do my best to show the general vicinity of where they're located. And starting off here, these pink threads within the gills, that will be both the afferent and the efferent brachial arteries, which are responsible for taking blood from the gills to the heart, or to the heart from the gills. Oh my god. So once again, with the brachial arteries, it will be a little difficult to see where they are, since dissecting arteries is a lot more difficult. So I'll be showing the general vicinity of where these structures are. Starting off here, we can see the afferent and efferent brachial arteries, which are responsible for taking blood from the heart to the gills, or blood from the gills to the heart. The dorsal aorta right in here takes blood from, actually I can show you right here, takes blood from the gills to the heart and to the rest of the body, while the ventral aorta, which would be found in the roof of the mouth, is responsible for carrying deoxy blood from the heart to the gills. And from there, it goes to the arteries. And finally, again in the roof of the mouth of the shark, we could find the internal carotid arteries, which are responsible for taking blood to the brain and the eyes. The shark right here, if I can just point right here, it'd be right around here, taking blood to the brain and the eyes. Next up, I'll be discussing the systemic arteries, which are responsible for taking blood from the heart to different organs. And some systemic arteries in the shark that we can observe are the coeliac artery, which will be right above the liver in this region, right around here. Obviously, it supplies blood from the heart to the liver. The gastric artery, which would be found in here, which supplies the heart, or excuse me, the stomach with blood. Gastrosplenic artery returns blood to the spleen and the gallbladder. Anterior intestinal arteries will be found on the intestine side, right in here, supplying the intestine with blood. And finally, the hepatic artery, which also supplies the stomach and the liver with blood, as well as the spleen, which will be found right in here.